In this lesson, we go through all the different types of filters that we have. So first of all, I'd like to start by adding one filter into this EQ, and I do that by just double-clicking on this yellow line right there, and it adds a filter there. Now I can choose what type of filter that's going to be. I can add up to 24 filters in this EQ. Now the first one I would go through would be a low cut. So this filter cuts all the low frequencies below a central frequency point that we choose. We can call this a low cut or a high pass filter, and these two names are commonly used through equipment depending on the manufacturer. So let's hear what this sounds like. As you can see, this filter cuts all the frequencies lower than the central frequency point we've chosen. Now, we also have a high cut filter, which does the same thing but cuts all the frequencies higher than the central frequency point. You might recognize these two because they're widely used in music today, as a special effect even, for buildups and breakdowns. But these are really important filters. So cut filters actually cut, attenuate down to minus infinite all the frequencies. For this one, for high cut, all the frequencies higher than the central frequency point we chosen. And for the low cut, all the frequencies lower than the central frequency point we chosen. Now let's go into shelving filters. The shelf filter actually affects all the frequencies lower or higher than the point. So we have a low shelf filter that affects all the frequencies lower than the central frequency point, and a high shelf filter that affects all the frequencies higher. But it doesn't cut them. It can either boost or attenuate. So a shelf filter actually looks like a shelf, and we can actually boost or attenuate. For high shelf, all the frequencies higher than the point we chosen. Let's hear that. And for low shelf, all the frequencies lower. Now let's deal with combinations of these filters. We have a tilt shelf filter, which gives us the low shelf and the high shelf filter in one. So we're getting them in opposite sides, of course. One piece of the spectrum is being boosted and the other part of the spectrum attenuated. And we can do that vice versa, just like that. Of course, we can choose when one finishes and the other one starts by just pulling the frequency point left and right through our spectrum. Now, a combination of low cut and high cut filters is the bandpass. So this bandpass filter is actually a combination of those two in one. So we are cutting everything lower than this point and cutting everything higher than this point. It can of course be steeper, and more about all of these parameters in the next lesson. As you see, a bandpass is a combination of low cut and high cut filters in one. So from this frequency, we are both cutting on the low side and on the high side of frequency spectrum. Let's hear that. Hence the name bandpass, because only this band of frequencies will pass through from whatever we feed into the equalizer. Now, the most common filter in equalizers is the bell filter. The bell filter, looking like that, looks like a bell, resembles a bell, and we use it to attenuate or boost a certain band of frequencies. Now we can of course choose how wide that bell is going to be, how wide the band of frequencies around the central frequency point is going to be, more on all of the parameters in next lesson. But for now, let's hear what this filter sounds like. So you see, I'm removing, but not completely, a certain band of frequency. So I can attenuate or boost a certain band, thus affecting the spectrum balance of all the frequencies we have in the sound I'm processing. Now, the last filter we did not go over is the notch filter. It completely removes one band of frequencies. You could say that this is also, you could call this filter a band reject filter, which it also has as a name in certain softwares. So it's rejecting one band of frequencies, completely removing those. Let me show you that. So we are completely down to minus infinite, removing this band of frequencies. Let's hear that. Let me just bypass that. So you see, those are all the different filter types that go into this equalizer. Of course, we can always add just more than one of those. This is one of the filters. Now this is another. This is another. We can also add, let's say, a cut filter. Let's try this. Let's see what this sounds like. Let me bypass and unbypass all of those. So by using all of these filters in conjunction within an EQ, we are shaping the spectrum response of the actual signal we are processing. This is why equalizers are a collection of filters. Now let me show you another equalizer. Now this standard equalizer within Ableton also has 8 filters, not 24, but 8. And we do have different filters for each one of these filter points. So we can choose a filter, let's say for this point number 1, it can be, let's say, a low cut or a not so steep low cut. We can also choose to be a shelf. We can choose for that filter to be a bell filter. So we can choose it to be a notch filter too. So all of the same things that we had as a choice in that Pro-Q 2 from FabFilter. The one thing we don't have is that tilt filter, which combines 2 shelves, but we can do that ourselves. Let's say make this one a high shelf and a low shelf, and we just replicated that one. You see that? And we can do it vice versa, of course. So we do have to take care of more parameters to actually achieve the same effect, but it is actually doable. So we have 8 filters and determine what each one of those is going to be, which type of filter we are going to choose for each one of these filter points. This EQ might seem small to you, but we can always expand it by clicking this triangle right here and having that filter shown to us large. Those were the most common shapes used in all equalizers, and they are mostly comprised out of exactly these types of filters.